Question number 11 of the PhilNITS FE afternoon portion of the exam. In this question, we are given a program that sorts the data in ascending order using the selection sort algorithm. If you are not too familiar with what a selection sort algorithm is, or maybe you've taken a course on algorithms but have forgotten what it does, the description gives us an explanation of what it does in terms of sorting the elements, where it says that the algorithm repeatedly selects the smallest element from the unsorted portion of the array and swaps it with the first element of the unsorted portion until the entire array is sorted. If we look at the program, we'll find that we got three blanks, A, B, and C, and we need to choose from the answer group which would be the correct answer. In my case, I ended up choosing the incorrect answer, but if we look at which ones are incorrect, because we got three blanks, turns out that only letter A, the blank A, was wrong. The other blanks turned out to be correct. So what that means is sometimes if you can figure out the other blanks but mess up with one blank, your answer would be incorrect. And so really it would be best if you can also make some type of writing in this way that we got here, so that you can clearly see if the inputs and the outputs match and whether the selection sort algorithm in this case is executing the way it should. Now we can go to the part where we've put in the correct answers. In our program, we can see that the elements are in a data of type integer array, and we need to go through each one. That's why we got the for loop here, except that in this case we need to go through only from the start until the element before the last. And the reason why we're doing that is because the next for loop, in this case, we will need to check the one after the current element in I. And therefore, if we are already in the element before the last, once we get to the second loop, we will be able to check the one after it. Because if we went up until the last element with our first for loop, in the second one, there won't be anything after it. And that's why, because in this case, we need to go through them and still use both for loops. We'll need to specify here as our answer for letter A, I plus 1. Okay. So the other thing too that I'd like to add is once we've sorted the elements, we don't need to go through them again. That's why 1 is wrong, because if we had to go through each of the elements over and over again, then that would be longer to finish. That would take longer to finish sorting the data. So once we've sorted the elements, we don't need to check them again. The next blank, blank B, is telling us that if we are gonna select the smallest element, then we need to compare our current based on the first for loop, the I, and the one right after it. And then if the one right after it is less than the current, which means it's smaller, then we set that to be the current smaller, or the smallest, current smallest in this case. and we go through up until the last element. We go through this up until the last element until we find the smallest. And once we found the smallest, we can swap it with the element that is the element with the position specified by the uh, I in our first for loop. Okay, so to better understand that, I think we need to go through the writing that I have here, my note about the steps that we need to go through. And in this case, again, let's write the input and the output, what we want to achieve, and then see if we can clearly see the steps. If this is our input, and we start off first with the first element, I equals to 1, and then in this case too, if we are gonna check the one after it, then I think this one would be set to the next one, plus 1 in this case. Therefore, what we'll find is that we'll need to compare whether the current I is, let me see if I can see the part here again. If the current I is greater than the next one. In other words, is the next element smaller than the current I? Okay, so in this case, we're comparing 12 and 11. We find that 11 is smaller than 12, so we set this to be the current smallest, but we need to go up until the last element, the remaining elements, and so we ask, is the next element less than our current smallest, which is 11? And we say no, and the next thing we need to do is go to the next one, which is 5. Is 5 less than the current smallest? And we find that it's smaller, so we now set it to be the smallest. And then finally we ask the next one, is it smaller, is it less than 5? 6 is not less than 5, so we find that 5 is the smallest, and we exchange their positions. That's why 5 goes here and 12 goes here. Now this part is already sorted, so we need to go to the next one. In this case, 11 is the current smallest, and we ask the next one, 13, is it less than 11? And we find that no, it's not less than 11. What about the next one, 12? Is 12 less than 11? We say no. And the last one, 6. 6, is it less than 11? And we say yes. So we need to exchange their positions, and that's why 6 goes here and 11 goes here. Now again, 5 and 6 are already sorted, so we need not check them again. That's why we go to number 3, I3, which is 13, and we ask the next element, 12, is 12 smaller than 13? Is it less than 13? And we find that yes, but there's another element here, and we ask, is 11 less than 12? And we say that 11 is less than 12. That's why we need to exchange their positions. Okay, so in that way, 11 goes here and 13 goes here, and 5, 6, 11 is already sorted. This set of elements is already sorted. That's why when we go to this one, I is equal to 4, the last element in our first for loop, we ask if 13 is less than 12 and we say no, and therefore we find that this would be the output 5, 6, 11, 12, 13, which is assorted data in ascending order, and which is what we'll get if our answer is letter E.